In this lesson, we're going to be focusing on distance and displacement. So let's assume you are taking a stroll on a Saturday morning and you walk from A to B, covering a distance of 10 meters, and then from B, you walk to C, covering a distance of 5 meters. So in this scenario, what is the total distance? What is the total distance you covered while making this journey or travel? So total distance is given by D1 plus D2 plus up to dn, where d1, d2 and dn are the individual parts taken in the course of the journey. So let's denote AB as d1 and then BC as d2. So in this case, your total distance is equal to AB plus BC. That is equal to d1 plus d2. So which will give us 10 meters plus 5 meters. So your total distance is equals to 15 meters. Alright, so that is for this first illustration. Now moving to this second illustration. Assume you are going to school and your school is located at point C. Alright, so this is your school. So this is just your school, and then your friend is staying at point B. So this is your friend's house. And so your friends ask you to come and pick him up while going to school so that you both can go together and gist together. So, and then you travel from point A to point B, covering a distance of 4 meters, and then from B to C, you and your friend cover a distance of 3 meters before reaching the school. So what is your total distance in this scenario? What is your distance? What is the distance you covered from your house to your friend's house and then to school? So what is your total distance? So let's also denote AB as D1 here and then BC as D2. So here your total distance is equal to D1 plus D2, which is equals to AB plus BC, which is equal to 4 meters plus 3 meters, which is going to give us 7 meters. So this is your total distance traveled. So I want to let you know that when calculating distance, we don't take into consideration the direction of motion. Alright, so it's all about calculating the magnitude, summing the magnitude you get. That is, this 10 is the magnitude, no direction, and then these 4, 3, all of them are magnitude. So distance doesn't have to do with direction, it's only have to do with magnitude, and that's because distance is a scalar quantity and not a vector quantity. So let's discuss displacement. Displacement is how far you are from where you started, or the shortest possible distance from the start of your journey to where the journey ended. So in this first illustration, the journey started from point A and then ended at point C. So in this case, your displacement is going to be from this A to C. So this is going to be your displacement, this X. And also take note that in displacement, we are taking into consideration the direction. So in that case, let's discuss this cardinal point and then Cartesian coordinate. This Cartesian coordinate. Now for this cardinal point, we have east, west, north, and south. Any motion towards the right hand side in a straight line is in east direction. Opposite it to the left hand side is the west direction, and then any motion up in this vertical line is turning towards the north direction, and then to downwards is the south direction. Now to this Cartesian coordinate, you have this x-axis and y-axis. You should be familiar with this one. So to the right of this Cartesian coordinate is positive x-axis, and then to the upwards of this vertical line, that's the northwest of this Cartesian coordinate, is the positive y-axis, and then downwards is the negative y, and then to the left of this positive x, that's opposite this positive x, is the negative x-axis. So that is to say that if here is 0, then here will be 1, here is 2, here is 3, and so on. And then here is -1, here is -2, -3, and so on. then here is 1, that's positive y, 1, 2, and so on, and then here is -1, -2, -3, and so on. Now coming to this cardinal point again, any motion that's in between this north and east direction is northeast. So anyone that's in between this east and south is southeast, and anyone that is in between this south and west is southwest, and then this one is northwest. All right, so let's come to this first illustration. Let's find the displacement of this first illustration. As we already know that displacement is how far you are from your starting point, so which is this x. So our displacement here, x, is given by AB minus BC. That's we want to find this x. So AB minus BC, this is going to be equal to 10 meters minus 5 meters. Now I want you to take note of something. This is positive 10, or I can write it as positive b. Remember, in displacement, we are taking into consideration the direction. Now this AB is pointing towards the positive x-axis. Take note of that, towards the positive x-axis, which we say that it is positive. So that's why I wrote positive 10 here. And then this 5 is going towards the negative x-axis, okay? Towards the negative x-axis. That's why this negative is here, okay? So we have 10 minus 5, which is going to give us 5 meters. And so we are going to talk about the direction. Now this is 5 meters to the west direction. So this direction here is west, okay, because this man here is moving towards A from B. So that is opposite the initial motion. So this is 5 meters to the west. That's the direction of this young man here now, and the displacement is 5 meters, then direction is west. That's 5 meters to the west. So let's look at this second illustration here. Now this young man moved from A to point B, and then from B to point C, and as we already discussed, that displacement is how far you are from where you started, and it is also the shortest possible straight line from where you started to where you finish the journey. So this young man here started at point A and ended the journey at point C. All right, so this is the shortest possible distance between point A and point C, so which is this distance here now. Okay, so we're going to find the magnitude of this distance here now. All right, so let me say that this distance A to C is x, and so you should be familiar with Pythagoras theorem. So that's what we're going to use to find this x. Okay, so Pythagoras theorem states that c squared is equals to a squared plus b squared. Now in this case, here is c, here is a, and then here is b. That is AC is c, which is this a here, AB is a, which is this a here, and then BC is b, which is this b square, this b here now. All right, so we are going to represent c squared with x. So we have that x squared is equals to a squared is what? A squared is 4, is 4 square. So this is 4 square plus b square is 3 square. All right, so this is s square is equals to 4 square is 16, that is 4 times 4 16 plus 3 times 3 is 9. So s square is equals to 16 plus 9 is what? Is 25. So let's find the square root of both sides. So this is x square, and then this is square root of 25. All right, so this square root we cancel these two here. We have that x is equals to square root of 25 is equals to 5. Okay, so this is the displacement is 5. So the displacement is 5 meters. Now at what direction? So remember I said that any motion that is in between north and east is northeast, and this is because if you draw this cardinal point here, you can see that this is east, this is west, this is north, and this is south. So this direction here is northeast. So the displacement of this young man is 5 meters to the northwest. So that is his direction towards northwest.